Hi, this is Chongkem. Welcome to Ruby Chess version 4, part 6. Okay, so before we begin, let's just run ctags. Just make sure everything is up to date. And let's run it. Um, okay, so we have the interface. We're able to make moves, and it ignores illegal moves. And okay, but the computer is not moving, so let's make it move. Okay, so let's open it up. Let's take a look at lib chessRB. Okay, so let's see. Okay, so when we look here, okay, so this is alphabetical. So here's position. Oh, see that there's two evaluates. So here's evaluate and evaluates down here. So let's just get rid of this one. All right. Okay, so let's make sure everything's still working. Okay, good. All right, so let's see. All right, so nothing else, no other duplicates. Okay, so let's go take a look at um, the game. Well, let's see. Let's take a. Okay, so Minimax looks like uh, it's there and best move. Okay, so I think it's just a matter of plugging this in. So let's go to chess, the user interface, and see uh, where we can add this. So here's position move. This is where the piece is being moved. So right after this, let's see what happens if, oh, actually before we do this, we need to say game end. Lib chess, and also let's take a look at spec. Okay, so we need to have uh, game end. Okay, so if we have, let's take a position where the king is checkmated. So that way we know that this is um, the game has ended. So game end, and this should be equal to true. All right. If you have a position, a brand new position, then um, game end should be false. All right. If you have a stalemate position, let's see the stalemate position. See, there's checkmate. Oh, should be stalemate. Okay, let's take the stalemate position and put it right here. And when we ask it game end, this should also be equal to true. So I think this is good for now. Okay, undefined method game end. Okay, just to speed things up a little bit, I'm going to modify the chess so that the depth is greater than 1. And this should make things a little bit faster. This is just for the test, and then I'm going to bring it back. Draw. So draw, there's an extra check here for checkmate. I don't think this is necessary, so just delete this. Actually, delete that and go back to the minimax and just replace this with, because I don't think I'm going to be using draw at all. So we know it's not checkmate because otherwise it would have been caught by this clause. So we can just remove that. This way we don't have to have um, uh, an expensive function being called twice. Okay, so let's see. All right, game end. So let's make game end. So how do we know if the game ended? So if it's checkmate or uh, stalemate or half move is greater than or equal to 100. Actually, instead of saying stalemate, we could just check for possible moves is empty. And we know it, okay, so possible moves empty. Okay, this should, because stalemate would I think, check, let's see, stalemate. Oh, it just says in check. Okay, but we don't need to um, do those statements because for minimax, this checkmate handles a lot of it, and so we don't want to duplicate the effort. All right, so everything should pass, and it should be a little bit faster. Let's see what happens if I change this to 2, see if it makes any difference. Still slow, but we'll just leave it at 1 for now, and then we'll just bump it up when we need to. Okay, so we have game end. Save this. There's some other things I think we need to do. Okay, let's take a look at move. Okay, in move, we have all this bit of code here that handles reading in the data, but the actual move happens over here. So all this logic, this is part of it, but it's not actually being used because we're not reading it from text. We're just reading it from the coordinates. So we do need to handle more situations here. So we need to go back to the spec and let's see. Actually, not the tag bar, but the set fd the fold method to be indent. So this way I could see this a little bit better. All right. So it should be under. There's move right here, and under move, it's with the 2 arguments. So right now we only have just um, one example. So we need to create more examples. Make sure that all the special moves like castling and en passant are handled. Okay, so let's see. Okay, okay, just getting rid of all of that. All right, so now um, let's handle, put it under context, or I could handle, okay, so under context for castling. Actually, okay, it castles king side. So if I have a position with a king on e1 and a rook on h1, and I make a move from e1 to e, not e, g1, this should be considered castling, and I should expect this to end up with a position with the king on um, g1, but the rook would also be moved to the f1 square, and the turn is black, and a half move is 1. Okay, all right, so that's 1. I'm doing it this way because if you read it without the comment, it becomes difficult to read. So having this is going to help. So okay, there's castles, king side. You also need queen side. So the queen side, the king is on e1, rook is on a1, and you're moving it to c1. So the king ends up on c1, but the rook ends up on d1. There is some other. Okay. In this case, because the king and the rook has moved, the castling option should not be there. So I could say, I could just make that explicit by saying um, castling should be just an empty string. Okay, and in this case, same thing. Since we don't have any black pieces, black castling should not be enabled, and because we already castled, that should also mean that um, the king uh, can't castle in either direction. Um, so I think that actually I might as well make it explicit over here. So if I have a king on e1 and I have a rook on a1 and on h1, and I move the king, so from e1 to e2, then I should end up with the same position almost. King is on e2, but the rook is on a1 and h1. But I'm going to explicitly say that uh, castling is going to be empty. Um, okay, and okay, so now the turn is going to be black. Half move is 1. Okay. All right, so there's a syntax error, which means that I must have missed, yes, square bracket. Okay. All right, so, okay, first, if the king moves, then we should get rid of the, okay, so let me show you the error again. The error says that it still thinks that white is able to castle, but this cannot be true, so we'll go ahead and fix that. So we'll go back to here and we'll say that if the piece, okay, so we have the piece here, and we'll say if piece is a king, then we're going to remove the castling. So castling, we're going to delete if you're white, capital K, otherwise lowercase k. Okay. And we also have to do it for the queen side as well. So you lose the ability to castle if you move the king. Okay, so that's good, but this is not correct, which is the king trying to okay, castle's king side. So we can see that the rook and the rook is should be on the left side, but the rook is still on h1 on the right side over here. So we need to fix that. So if okay, so we know it's a king move, and we can put some additional things in here saying that if from 2 minus from is equal to 2, okay, this means that it's castling king side, then we need to move the rook that's on the h1. Okay. Actually, that is going to be nil, but before we do that, the target square is going to be f1 is equal to whatever's on okay, so that moves the rook. Okay, and king e1, undefined local variable method from. Oh, I don't have from. So from is going to be arg0. I'll just replace this with from. Okay. All right. So this is castling queenside now, so we have to also handle queenside. Syntax error on line 269, so 269. Okay, it's because it's just warning me that this variable shadows the I'll just call it temp from. Maybe I should call it underscore from. Yeah. Okay. All right. That's 288. Okay. Another one over here. So I'll just do from like this. Okay, there's from. Okay. All right. Okay. All right, so castle's queenside. It doesn't know about castle and queenside. So, and we got rid of the syntax errors. So castling queenside. Let's go to move. Okay. So when you're castling kingside, now it's going to be -2. So, okay, so it's just a matter of switching these. So this is the rook. So the rook is going to end up on D1. And the rook is coming from A1. And so the A1 square is going to be empty. Okay, all right. So we have the king taken care of. We also need to take care of, let me see. All right. Okay, so we also need to take care of the um, pawns. So let's write the test for the pawns. This is I don't like it when it wraps like this, and I also don't like it if I don't want to shrink the like shrink the font. Let's see how many. It's about 147 characters going across. All right, so it's going to put a little break in here. So where that equal is, I'm just going to put, instead of doing this, this causes confusion because without the parentheses, it doesn't know where it ends. So um, this will make it as if it's continuing the line. Okay, and this one, okay, I might as well make this, put a little label on this and say that it removes castling if the king is moved. Okay. All right. Makes it a little bit easier to read. This one's a little bit long, so I'm going to break this out as well. All right. And this one's kind of long too. All right. All right. So this way, at least you can see the position all in one row like this. Okay. Pawn promotion. Oh, actually, pawn moves. Okay. So, interesting. For the 2org, we have the pawn promotion over here. But we need to do en passant. So actually, let's do the other form. It handles en passant. Okay, so you start off with, let's see, en passant. We have a position where actually just the pawn on E5 and a black pawn on F5 with the en passant square being the F6 square. Okay, I think that's all we need. And we make the move from E5 to F6, and that should be a legal move. That's en passant. So then the end position, the resulting position should be the pawn on F6, and there is no other pawn, no black pawns because it's been captured. And so, see, en passant should be nil. Actually, we can probably skip that because by default it would be nil. let's see, turn is black, and a half move is still 0, so we don't have to include that. So I think this is it. Okay, Abba Song. All right, let's. I must have missed something here. Expect to equal that. Okay, must have missed a curly brace or something because let's see what the error message says. String expecting curly braces. Okay, so here's the expect to, and here's end curly braces, but we don't need the end curly braces anymore. Okay, so this is the en passant, handles en passant, and the pawn is still there, so we need to get rid of that pawn. If we detect that it's an en passant, we have to remove it. All right, so let's go back to the code, and this time we say if piece is a pawn. Okay, and how do we know if it's en passant? If 2 is equal to the en passant square, then actually I'm going to join these two together because I don't think there's any other special thing that needs to be done for pawns. Okay, so like an extra move. Okay, so for the pawn, if that happens, then we need to remove the other pawn. So we do that by, okay, first, we know the en passant square. That's where the piece is, but we have to add, if you're white, you have to add a row, and we do 10. Maybe it's a good time to replace 10 with width, because, let's see, we'll just leave it as 10. But if I had more time and if I didn't want to bore you, I would probably just do it if I were doing it myself. But since I don't want to bore you of just replacing a name, I'm just going to leave it there. Okay, so 10 or negative 10. And we're going to set that to nil, so we're going to get rid of it. Okay, so everything passes. All right, are we done? Actually, I think I will change it all to, no, if I do, then chess helper, this would need to change, and then there's just too many places in the code. Like it would have to be some type of global variable inside of chess helper because it's in array and it's in a whole bunch of places. So yeah, it doesn't really buy us anything, and I think for now we'll just leave it. Okay, let's see. Okay, so let's plug this into the game. So let's go. Actually, it's not the game. It's chess.rb. Okay. Okay, so here's button up. So in button up, we make the move, and let's have the computer make the move. So if not game end, then let's have the computer move. So the best move is going to be okay, whatever happens to be the best move at the time, and position is position dot move of the best. And I'm putting a star in here because this will return a list. So the list will look something like the from location to to location, and possibly the piece where if the pawn is going to promote. And because I want to pass this in like this, then that's why I need the star. Otherwise, it'd be sent in as a list. I want to be passed in as arguments. Okay. All right. So let's see how this works. I don't need to run the tests anymore, so I'm just going to disable that. Okay. And let's go to here and just run it. All right. So now when I make a move, I'm going to expect the computer to make a move. Interesting. Oh, undefined method move for nil class. See what happened here. Um, hmm. Oh, this is okay. Actually, let's see, what did I have move to? Let's see, what does it return? It returns self. Okay. Just see if this makes any difference. Undefined method move for nil class 66. All right, so let's see if that happens again. Yeah, it looks like it's probably happening again. Oh, actually it didn't. Interesting. Why did that happen? Let's do this again. This really shouldn't have made a difference. So if I run this again, I make a move. Does it crash? Yes, it crashes. Let's see what's up with this. Even though we know the solution, it just doesn't make any sense because it's supposed to return itself, and so it really shouldn't have done anything. 66. Okay, so let's see what 66 is. Oh, it's under show. Undefined method move for nil class. Oh, it's on 36. So 36. Okay. Interesting. So, okay, this is very interesting because it thinks that position is nil. So let me put a debugger in here and run it. So now the debugger should kick in. All right, so let me take a look at position. It's nil. This is almost impossible because here you have position that best move, and so it's actually being called. But over here, let's see, this looks like this is very interesting. This seems like it may be a bug in Ruby because there's no reason why position should be null. Actually, let me just get rid of this assignment statement. And if I run it now, okay, so I'll just make the same move. Okay, now I get to the debugger and I say position. And I have something. So I think what's going on is that because position is I think this is a bug in the language because position exists, and then when I made that assignment statement, it didn't exist. So that's a problem. Okay, but anyway, let's continue from here. So all right, let me just run it. Okay, so let's see how the computer plays. Okay, it takes a little bit of time, and it's going. And I'm just going to make some. Actually, let me try to win here. Okay, I don't know if you noticed that, but I made the move, but it took a long time. but it's only after the computer finished moving that it got updated. So we need to fix that. So let's quit out and move this. So this needs to be done someplace else, and we could do that under update. Okay, this function is going to be called every fraction of a second, and we can just do it based on the state. So we'll just say player is computer. Actually, not computer. It should be player. All right. And inside of update, okay, we can move this in here now. Okay. We only want this if the player is the computer. Okay. And then we have to make sure we reset it. Player is equal to human. Okay. All right, so let's see how this works. Okay, so now when I make a move, we still have that same problem. So it only updates after. So which means that this is happening too quickly. So as soon as we finish with the button up, it goes into the update and it does it immediately. So we want to do it in the next tick, and we can do that by just creating an intermediate step. Okay, that's the player. Okay, so instead of computer, I'm going to say computer wait, and case player when the player is computer wait, then player is going to be computer. So now the next time around, it'll do it, and I'll just change this to a when. Okay, and then when it's a computer, then we actually do it. So let's see if this makes a difference. So now it's going to wait a tick. Okay, so I make the move. Okay, it shows up immediately, and now I can see the it doing the update. So let's see how long this actually takes. So under so when this happens, when it's the computer's turn, I'm gonna just print out that computer start. Okay, and then at the end of it, I'm going to say computer ends. All right. All right, so I'm going to make the move, and you can see that the computer's thinking, and then it makes the move. All right, so let's continue playing from here. All right, so you can tell that the computer is not doing, it's not very smart. Okay, and okay, it looks like it tried to avoid a checkmate. I wonder if that's real. Hmm. Now I'm going to try a different move order and see if it tries to avoid checkmate again. So because if it does, then doing that one level deep search does help. So I'm going to change this around, and now I'm just going to make an arbitrary move and see what moves it makes. It just moves the rook back. So I think it is okay. Now I'm going to try to see if I can checkmate. And it looks like it's doing it deliberately to avoid being checkmated. So that's pretty good. But it's making terrible moves because it's not making any development at all. And the reason why is because as long as it has all its pieces, all position looks the same. So what I'm going to do is I'm going to give it a little bit of smarts. And let me see. Let's go to the lib chess here, and let's go to evaluate. All right, under evaluate, all we have is just this. But in chess, when you're doing an opening, you want to try to control the center. So what I'm going to do here is say if the full move is less than 10, then we're going to do this calculation. And I'm only saying less than 10 because anything more than this, and you're starting to get into the middle game and then the end game, and they all have different purposes. So in the beginning, you just want to bring your pieces out. So for the first 10 moves, let's just consider that there are 4 central squares. So E4, E5, D4, and D5. Okay, each do. And this would be IDX. And let's say all the pieces. So let's have a thing called pieces. Each do. Okay, piece. Okay, I don't think we have pieces, so we need to create this. So under chess helper, I'm going to create pieces, and that's going to be rook, knight, bishop, queen, king, pawn, rook, knight, bishop, queen, king, pawn. Okay, and then I need to do this. Okay, so now I have the complete set of pieces. Okay. Interesting. Okay. I wonder. Maybe I don't need to have it global because I don't think I'm going to be using it anywhere else. So let me just do that right here. All right, and now let's just say each do piece. All right, so we have all the pieces, and the score is equal to, and um, if the piece is okay, I think let's see, white. Okay, if it's white, actually, let's see what white is defined as, and it has the turn. Okay, so it's going to be -1, actually +1 or -1. Actually, I'll just do it. I'll just separate it like this instead of having it all like that. So each do piece. Actually, I'll just do it this way. So P score plus equals find the piece that can go to the square, and we do a size. And how much do we think it's worth? Let's just say it's worth just 1 pawn. Actually, let's say it's worth 2 times 2. Okay, and we do the same thing here for the black pieces. Okay, score, we subtract it though. Okay, times 2. And we also want to give a little, some points. Actually, I think we need to invert this. Okay. Yeah. So we have this right now, and e4, e5, d4, d5, each do idx. And actually, let's just do it like this. Okay. All right. The reason why is because we have, those are the center squares, but the other squares are kind of important too, like the ones that surround it. And that would be E, E3, E4, okay, so E starts with the C, C3, C, D, E, F. Okay, those are kind of the, okay, and then I think, okay, let's just keep it like this for now. I think I'm getting really ahead of myself. Okay, so might as well just okay, and see. Just first all of this. Okay. Yeah, just bringing it back to the way it was. All right. So let's see if that makes any difference. So basically, this is saying the center squares are important, and we're going to count how many pieces are attacking the center squares. So we give it a little bit of an incentive to try to control the center squares. So let's see if it plays a little bit better. Now this is actually a much better move. Instead of just shuffling back and forth, now it's trying to control the center. All right, so let me try to do the same trick. I'm going to try to do a checkmate. Okay, so that's all right. That's good. All right, so that's still a decent move. Oh, the queen moves. Now this is really bad. This is really bad because if I take, then he loses. He just loses a piece, and I think the reason why it considered this a good move, a comparable move, is because it's controlling the centers, and this is taking way too much. It's taking way too much precedence over this because this is worth 3 pawns, and it's not worth that much. So we need to adjust this. So let's go back here and for the evaluate, it's not going to be worth 2. Let's say it's worth 0.2. Just give a little bit, not too much, because otherwise it'll sacrifice pieces for trying to control the center. Okay, actually 0.1. Let's just do 0.1. Okay, so a slight advantage. Oh, actually 0.1. Okay, Ruby doesn't like it when you start with a dot. Okay, so let's see. All right, so let's see how it plays. So it's enough to consider the same moves. This is good. Okay, knight out. That's good. All right, this is interesting. Okay, why it made this move? You would think that it would probably make a move like this, because then it would control. Actually, it wouldn't control the square. It would still at least think that it can go here. Okay. I'll just keep playing, see what it does. Okay. This is interesting. This is making pretty bad moves now. Okay, and it's shuffling. So I'm going to castle, so the castling works. That's good. And the rook is just shuffling back and forth. Um, I'm going to try to see if I can. If I do bishop takes, that would be checkmate. And it moves a pawn to try to avoid the checkmate, which is good. Okay, I take. And it moves out of the way. And see. Okay. And if I push this, okay, the queen takes, and it's not playing a very good game, but it's not making random moves. I mean, it's actively trying to avoid being captured. So this is what happens when you have one move look ahead. Let's see what happens if I try to attack the queen. This bishop isn't protected, so I expect the queen to take the bishop. That would be considered a good move. And it did take the bishop, which is good, which means that the algorithm is working. So let's see what happens if I do a check. Hey, it took. I'm very surprised. I take back, and computer's still thinking. It moves the rook. Okay, now I'm going to try to win. And because it's playing badly, and I'm down material, but I'm thinking that because it makes terrible moves, I should be able to beat it. See, but it's avoiding very simple attacks. So if I can't just move my knight over here where this queen is and expect to be able to take the queen, because then it's going to try to avoid being taken. But it doesn't know anything about position except for the center. And I think we may be past the point where the center is important. So let's see. So the next thing we need to do is figure out how to do as many calculations as we can, because right now we're just doing a depth 1. So and I wonder if it knows about checkmate. Actually, that's an interesting point. I'm going to lose all my pieces, and I'm going to see what happens. Okay, and see if it can checkmate me. If it'll find, well, it took my queen, which is good. Okay, and it should take that pawn, and let's see. Okay, it's good. It's avoiding being taken, which is good. Okay, it's putting me in check. I have to move. It's putting me in check again. Okay, I'll block using my rook, which is not a very good move. And it took the pawn, which is very good. It's actually with just one ply look ahead, it's not doing bad. Okay, but can it checkmate me? That's the question. Kind of helping it along. Oh, took the rook. Okay. Just taking everything. But I captured the queen. Now this is going to make it more difficult now, because without the queen, it's going to have a harder time, but it has to bring those other pieces out. So, oh, the computer, oh, I misspelled computer over here. Okay, so it's my turn. And let's just see what it would do. If I don't do anything, I wonder if it's going to keep on shuffling. The computer made a move. I wonder what, okay. Okay, so it's moving the rook back and forth. So, yeah, it's still moving it back and forth. I have a bishop here, so I'm going to see what happens if I try to, okay. Okay, now it knew that if it moved the rook over here, I was going to take this pawn. Okay, um, so right now it has no direction. Let's see, uh, let's take. All right. Um, there's no way that I could really win here. But black has no concept of what it can do. So everything else, it has no strategy. So one ply look ahead is only good if you're trying to avoid um, being mated or simple capturing. But it doesn't know anything about strategy. Okay, so yeah, it's just going back and forth. And if I go back and forth, it'll go back and forth. Okay, it also doesn't know about threefold repetition. So, all right. So I'm gonna quit out. All right. So actually, another thing that would probably make this play a little bit better is how close the pieces are to the king. So just as we have um, pieces that can attack the center squares, let's say that after the 10th move, um, if full move is greater than 10, actually we can just put an else here. So let's give it some bonus points if first we have to find out where the king is located. Let's see. I'm going to split this so I can take a look. Where is the king located? Let's see. Piece. I thought I had a variable that kept track of the king positions. King. I guess not. Well, index k. I think that's how I just did it. I just do it as index k. Okay, so that's what I'll do. I'll just use the index k. All right. So um, so it depends on okay the king position. We need the king position. Okay, so where is the king located? So king index is if you're white, then we say board dot. Actually, we can just board index. If you're white, you're looking for a capital K, otherwise a lowercase k. Okay, that's the king position, and um, I'm gonna say if king ID X, then the reason why is because there are some positions where there are no kings, not in a game, but in our tests. So I don't want our test to break. Um, so I just put this in a condition. Okay, so let's do the same thing as this, and right, actually, there are two kings, right? There's the white king. Okay, index is equal to index of k, and black king index is equal to index of lowercase k. All right, so if the king index, okay, so if white king index, then we're gonna do this. Okay, find a piece that can hit the um, white king index, but it should be the black pieces. So it should be score find the piece that can white king index. Okay, see if this looks right. Might as well put the if white king index right here and just take this out. Okay, and then this. Okay, so see, if you're going to be hitting the white king, then that's more advantageous to black, so we do a subtract. And for this, we do plus. It's the black king index. See, 0.1 if black king index. All right, so let's see if this makes a difference. Let me see if, okay, make a small change, and now let's see how it plays. Okay, which is kind of expected. All right, still very similar. Protect. Okay, that's what it did last time. And I'm just going to develop. Okay, so still random move because right now none of the pieces can immediately attack the king. But now I'm going to start losing all my pieces and see if the... all right, so let's start losing pieces. Okay. Okay, let's move the knight back. Oh, the knight moves there. So I'm going to start losing my bishop. Just going to castle, and it should take my bishop. Okay, it did, which is good. I'm going to do this. Let's see. It avoided the rook being taken because it chose the rook over the knight because the rooks are more precious, more valuable. Okay, I'm gonna lose my queen now, and now this queen is going to come out. Great. So I'm hanging my knight. Okay, it took my knight. Okay, so let's see. It's playing. Oh, it took my bishop. Okay, check. Good. All right, and I'm going to push this pawn. See if it'll take it. It took. So it sort of frees the bishop. I think that for now, the reason why it's not moving any of these pawns is because um, with only one look ahead, one move look ahead, it it can't distinguish whether any of these moves are good, and they're all equivalent. They come to the same value. So this would be the first move that it would consider, and so yeah, because the king can't go here, the bishop can go here, but it's not including that. Yeah. All right, so I'm going to lose some more pieces, and I'm going to bring my king into the open. Okay. Check. Ah, it's giving me a check because, oh, and it took a piece. Yeah, that would be better. Let's see which piece it would take it with. Okay, so now it's got a bishop there. Let's see if the bishop is going to check me. It doesn't. Okay. Okay. So the reason, okay, so now it checks me because it sees that. And let's see if it can coordinate between the bishop. Okay, the bishop took. Okay, I'm gonna, okay, the rook takes back. And, okay, oh, the rook went back. Interesting. I'm going to just shuffle back and forth, and the rook is still shuffling back and forth. Okay, so okay, so it still can't. It doesn't have enough brain power to even with the pieces out. It still doesn't consider it. It considers it pretty much um, the same value. So what we really need to do is go in here and increase the depth. So this is going to take a little longer. I'm going to change it to 2, um, and let's see how this will take a little bit longer, but let's just see how it plays. All right. I'm going to speed up the video here because since it's going to take a while and there's nothing going to be happening, so I'm going to just speed up the video and we can just play a game. That took a very long time. I think what would be good the next time I modify the code is to print out how many nodes it's looking. So this way I get an idea of the size of the problem, because when it's stalled like this, I really can't tell what's going on and how many nodes it's looking at. Um, so it would be really good if I could see whether it's looking at 100 nodes, 1,000 nodes, 10,000. Right now I have no idea. And let's see. So far it's playing a very good game. I mean, it's not. It's playing at a level that is uh, decent, but not uh, a great player. Sort of like a smart novice. Even if I wrote this program in a different language that like C, uh, and we saw that when we wrote it in C, it was about 7 times faster. Yeah, it made the move. Interesting that it made the move, but the printing doesn't come out until a little bit later. Um, okay, um, it's very interesting. It just loses that pawn. Another heuristic that I think would be interesting is if um, I gave it a very like 1/10 of the amount of points um, of hitting the king as the opponent pieces are away from the king. So this pawn, if it was closer to the king, that would be better than when it isn't. So hopefully by doing that, maybe it would open up these pawns and allow it to have a lot more possibilities. Because right now, um, it's better than it was playing before, but it's not doing development. It's not bringing these pieces out. So I have to figure out a clever way um, of telling it to develop. And um, well, I think there are other ways to give an incentive for it to develop, because you don't want to say move this pawn if it's third move or something like that, because you don't want to give the solution to it. You want it to find a solution. At this point, I'm going to start losing my pieces and see um, if it can mate me. So after it makes its move, I'm going to start sacrificing my pieces. So So the next time I'm going to do this, instead of doing it by depth, I'm going to do it by the number of moves. So eliminate by the number of moves it looks at. So this way it'll be more consistent in terms of time. There is value in working in a language that's slower because you have more of an intuitive feel of how important certain things are. Because if things are just too fast, then you can't distinguish between um, uh, the subtleties between some modifications. So it seems that one of the lessons I'm learning from this is that what I need to do is put a lot of thought behind the evaluation and less on trying to optimize for how deep it should go, um, because if I make this one level deeper, then making this program 7 times faster um, would make things a little bit easier, but still it just delays the problem because just looking one ply more is not going to terribly alter um, the situation. So I'm going to start thinking about how I can improve the evaluate function to do more, even if it takes a little bit longer to do. And at this point, the computer um, should run a little bit faster because as the pieces are taken away, uh, that means that the tree of what it needs to look at is less bushy. Um, so the possible moves are a lot less, and so three plies deep will uh, okay. This is pretty good because now I'm going to take. I'm going to see if it sees if it can checkmate me. And this is checkmate. There's nothing I can do here. So it was able to find the checkmate, and it did it in a very sneaky way. So I'm pretty happy with the way this program turned out. Um, I will continue to, maybe the next session will be the last session, but I want to see if I can make improvements on this. Okay, so see you next time.